Hey, how you doing? My name is Taylor Hayes. I'm here to talk to you about Chapter 5, Section 3, Metabolic Pathways and Enzymes. Reactions do not occur randomly in the cell. Just as a house is built in the series of ordered steps, chemical reactions in the cell usually occur in a particular order. They are part of a metabolic pathway, a series of linked reactions. Metabolic pathways begin with a particular reactant and terminate with the end product. For example, glucose is broken down by a series of consecutive reactions until the end product CO2 and H2O. So now enzymes. Enzymes, which are protein molecules that function as organic catalysts to speed up chemical reactions. That's what they do. They function as organic catalysts to speed up chemical reactions. They also bring together particular molecules and causes them to react with one another. Follow me as I give you an example of what enzymes do. All right. Here we have, let me get a arrow, B, arrow, C, arrow, D, arrow, arrow, D, arrow, F, wait, A, B, C, D, E, F, E, F, woo! We don't need it, G. Forget it. Alright. A is the reactant, B is the product, C is the reactant, D is the product, basically. And here's E1, E2, the E stands for enzymes. Enzymes react, and you got your reaction product. A, B, and C could be a reaction. Is a reaction of D, B, and F. It's basically a reaction of the product G. Okay, no E. All right, and then you have this is you got substrates. This is another diagram. You got your enzymes, substrate, enzyme. All right, you got your enzymes, E for enzymes, substrate, reactant. And you got E for enzyme. And P for product. All right, the substrate goes to the enzyme. This is what you call your active site. AS for active site. The enzyme changes shape to fit the substrate. It's called the inducing fit model because it changes shape so it can fit the substrate. Once it fits the substrate, it reacts. This is where the reaction occurs. Once the reaction occurs, it does its thing. It mingles. They break apart. And then the enzyme, it goes to free when the product leaves the enzyme. This is no longer a substrate, it is a product. The enzyme is free to go mingle with plenty more substrate. That's how that's my basis of it. And you have enzyme enzyme inhabilitation. Enzyme inhabilitation is basically whatever the function that stops this. It stops this from occurring. Once it stops this from occurring, you die. Because without energy, you die. Without ATP, you die. The book defines energy by being able to do something. There are two types of energy: potential and kinetic energy. Potential energy can be explained as